So if you've ever seen me talk at conferences before, which I do, specifically ColdFusion ones, I probably heard me talk about AWS and S3 in particular. I'm a big fan of S3. I always encourage people who haven't done any cloud stuff yet to start with simple storage service because it's so easy and simple to work with on a lot of levels. I can do a lot, but it's really easy and simple to work with. It's awesome, easy to use, I think it's fun. You know, our keynote speaker this morning talked about doing things that you find to be fun. I'm one of those weird nerds who finds AWS and S3 and stuff like that to be fun. And it's great because S3 lets us store all the things we might possibly ever want to store for our applications, our code bases, our artifacts, our video files, whatever it is. You can just store this stuff from whether it's 1 byte up to 5 terabytes in size for an individual file. It's super fast, it's highly scalable. People call it the file system for the internet because companies like Instagram use it, among others. And if I could go back in time and put all of my user data and all of our sort of non-code artifacts into S3 across all of our applications, I would. And my team spends lots of time still migrating stuff off local file shares into S3. And ColdFusion, or ColdFusion engines, whichever one you might be using, make it really easy to use S3, right? Super easy to do this. Because ColdFusion has had support for S3 since ColdFusion 9. So all you do is, instead of a local file path, you just say S3:/ to indicate the files reside on S3, and ColdFusion takes care of the rest. It's super duper easy. It's almost too easy, right? It is too easy, because what happens when we do this oftentimes is we say, well, I'll just sort of build this prototype using S3 because it's so easy to do, and I'll leave the bucket open now and figure this out later on, and change the permissions when it goes into production, because you know it has this crazy name that I made for my bucket, so no one's ever going to find my bucket on S3, right? But they do. They always do. So let's look at some examples of getting seduced by the power of S3. These all happened in the last 12 to 14 months. Verizon left names, addresses, account details, and personal identification numbers of 14 million customers in an open S3 bucket. Dow Jones left sensitive personal financial data for 2.2 million customers of Dow Jones in an open S3 bucket. FedEx left customer passports, scans of passports and driver's licenses in an open S3 bucket. The Republican National Committee left 200 million voter records in an open S3 bucket for anyone to find and access there on the internet. Macy's left profiles including addresses and dates of birth. That's not personally identifying information. In open S3 buckets for anybody to find. Booz Allen, one of their subcontractors, left battlefield satellite and drone imagery in an open S3 bucket for anyone to find. The National Credit Federation, 11 gigs of credit card numbers, credit reports. This is a group that's supposed to help you get out of credit debt. Left this in an open S3 bucket for anyone to find on the internet. And it's easy to fall into this trap because when we're freed from having to worry about infrastructure, when we can just build, right? It's easy to just build. So we build prototypes, and those prototypes somehow manage to make their way into production, and then those prototypes reflect our sort of lack of forethought about key things like security. And security is boring, right? But making apps, making new things, serverless applications, that's fun stuff. And you know, unsolicited but very obvious advice is that we have to think more deeply about the authentication and authorization strategy before building. And because a lot of times we don't. We just do that principal star. And we'll figure it out later because it's the easiest thing to do in Amazon, at AWS, or Azure, or GCP. And in Amazon Web Services, Identity Access Management, or IAM, controls both authentication and authorization. And although I'm talking about AWS IAM specifically today, the same principles apply if you use Azure, if you use GCP, if you use the Google Cloud Platform, or use Azure Active Directory. My name is Klaas. I work at the Johns Hopkins Bloomberg School of Public Health. If you've ever seen me present talking about AWS before, using AWS from your CFNL map before, I usually offer a disclaimer that I'm never going to talk about IAM because it's so big and complicated and difficult to work with. But today, if you're going to move beyond read all, having these kind of gross open permissions which leave you open to all sorts of attacks and huge giant builds that are unexpected, because that happens too. In order to really work with any of the services in AWS, whether it's S3 or Lambda or whatever it might be, you have to get to know the intimate details of IAM. It's a simple reality. You've got to get to know this sooner or later. And really, I'm going to talk today about aligning permissions for user permissions in the ColdFusion app with services and how those services might be used in AWS or Azure, in GCP for that matter. I'll give a disclaimer right up front. I cannot possibly cover everything there is to know about IAM in 50 minutes or less. I just can't do that. At reInvent, which is here in Vegas, in about 5 weeks, 6 weeks, there are probably about 150 to 200 individual sessions on IAM and using IAM. reInvent has about 5,000 sessions in a week. That's how big it is. But they have 150 to 200 just on IAM, so I can't cover everything that I would like to cover, but I'll try to give you some good tips and guidance on that front, particularly from the ColdFusion side of things and how to manage it all. All the code I'm going to show is in my AWS Playbox app. There's the URL, my GitHub repo. I'll show this URL like 5 times, so if you don't grab it right now, don't worry about it. I promise this URL will come up many times and you'll be able to see it. Okay, and by the way, as I go along, if you have questions, just ask. Otherwise, I'm going to run my mouth until it's lunchtime. So just feel free to ask questions or save them to the end. I'm always happy to ask questions about IAM or anything else in AWS, since I work with it a lot and I work with ColdFusion applications in working with AWS a lot. All right, so the basics. IAM, Identity Access Management. This is the backbone of authentication and authorization in AWS. Every single request that's made to AWS, either internally or externally, runs through IAM. So, as you can see in this sort of detailed out figure here, so a request comes in from a user on the internet and hits AWS's Internet Gateway, and IAM immediately goes to work and says, does this request have authorization to even come into AWS? Yes or no? It says yes, it says cool, passes it on to a load balancer, maybe in your own virtual private cloud. It says, does this request have permission to get to this load balancer? Yes or no? Does this load balancer have permission to then pass that request on downstream to an IIS or web front end? Yes or no? So it takes the web front end, you can say yes, and then it says, okay, does this IIS front end have permission to call the database? Yes or no? It says yes, goes down to the database. The database says, does this request have permission to access this particular database, this particular table, run this particular function? Every single action in AWS uses IAM. This is millions upon millions of requests per second to this service, right? In each of the 22 regions that AWS has around the globe. Imagine being on the team that runs and builds IAM. You make one mistake deployed to production, and it brings down all of AWS, and therefore half the internet, half the sites on the internet in the process. It's an immense amount of pressure. I would not want to be on that team for any amount of money. It's terrifying. But it's important. It runs everything. It's all the application, all the authorization in AWS. And there's basically 4 components to IAM that you need to know about. Policies, roles, groups, and users. And I'm going to talk about each of these in turn and show you how you can work with them from your ColdFusion applications. So let's start with policies, because at the end of the day, mastering IAM is about mastering policies. It's as simple as that. If you can figure these policies out, if you can write them the right way, you have mastered identity access management in AWS. And policies are just JSON structures. That's all they are. They're just JSON structure. I think any of us can write that. It's not very hard. It's figuring out what goes into that structure in the right way. That's the challenge. So let's take a look at a policy here. And this is a very, 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 very basic policy. And I'll sort of step through it so you can see what each component is about. And again, these policies apply not just to the example of S3 that I'm going to use here, but really anything, any service you want to use in AWS, you have to write policies for and say that these roles, these groups, these users can do these things with these policies. So there's a version of the IAM policy language. It doesn't change very often. As you can see, 2012 was the last time policy language was updated, but you have to include that. And then there's a policy definition block, a statement that says, here's the things that this policy can or will allow or won't allow. That's followed then by an effect statement. And there's 2 options for the effect, either allow or deny. And most times you'll see policies that are written to say, these things are allowed. And I'll show you one later on that talks about denying things. And then you specify who can do this. A principal, that's what they call it, a principal. So in this case, I'm just using the wildcard pattern match, right? I'm saying anybody can do this, right? Star means any principal. Anybody, anyone on the internet, anyone in AWS, anybody can do this. And then we have an action block where we say these are the things you either want to allow, if the effect is allowed, or deny, if the effect is denied. And that's just an array of individual actions. And here we are listing the action names that we want to allow. In this case, I'm saying S3 star. So that's any action in S3. Any action in S3 at all. And then we point to a resource, meaning a thing, an object, a service, a server, a file, a SQSQ, whatever it is that you might be using, that you're going to say this policy applies to these resources. And here, then you list those specific resources, the ARN or Amazon resource name, the specific resources. And again, I'm doing a star, so anything you match there. So by the way, the ARN is something you'll see listed a lot when you write policies, when you work in AWS. ARN just stands for Amazon Resource Name. It's the unique identifier of that thing in all of AWS. So across all 22 regions, whatever your bucket name is, whatever your Lambda function name is, whatever your SQSQ name is, it's there. And they're all in different formats. This is one of the great things about working with AWS, is that things are largely inconsistent. So you'll get, for example, a bucket name, the ARN looks totally different than CloudFormation stack, which is the way you can sort of do infrastructure as code, which looks totally different than the SNS topic or the name of a Lambda function. And these ARNs are available in each of the different tools you might use. So if you go into the Lambda console, you'll see the ARN of your function. If you go into S3, you'll see the ARN of your bucket there. But that needs to be put into your policies if you want to specify resources in your policies. So here we have a policy that, if hopefully you can read this now, that says anybody can do anything with any of my buckets in S3. And there are real life policies out there in the world just like this, because this is super easy to get started with, right? When you're a developer and you don't know what you're doing, and you're trying out S3 for the first time, just open it up, it'll be super easy, but it's a terrible, terrible thing to do. This is how people get literally hundreds of thousands of dollars in charges in a matter of hours on their S3 buckets. There are people out there, people who are hackers, go out there and they scan S3 buckets and they find open ones and they start dumping terabytes of data in. And guess who's responsible for those charges? You, the person who opened up your buckets that way. So never, ever do this. Now this is another policy that looks very similar, right? Cool. This is saying, instead of S3 star, meaning anything you want to do with S3, we're just going to say S3 read, which makes this bucket called my special bucket read only. Cool, that's great, but that's also bad to do because there's all sorts of metadata you can glean about your account just by saying read star. Any kind of read functionality that might be in S3. It's also bad to do. It's super important when you're working with IAM, when you're writing policies, that you are as specific as possible and allow the least privileges that make sense to people who are doing this. And yes, this is going to lead to developers asking for new permissions all the time for new services that they want to use. When AWS launches another service, they'll say, hey, I want to use Textract now. You add that to my IAM policy. You have to go through that process, but it's also going to avoid surprise bills, which are an issue. Or thousands of dollars, or who knows how much dollars, of accidental deletion of IAM or AWS resources. Then this happens, right? If you don't say, don't let someone delete a database, someone will delete that database sooner or later. This has happened to me. I've lost application stacks, load balancers, database tables because I didn't go in and specify that delete operations, including drop the whole database, wasn't allowed in the IAM permissions. Yes?
This whole policy you're talking about, where does this apply at some sort of global level that governs all your AWS?
Excellent question. Where does the policy apply? I'll talk about that as we move on, but it applies basically, you can set it to both individual compute instances, meaning EC2 instances. You can apply it to individual groups that you can set up, and individual users as well. So you can apply these at a number of different levels. And I'll go through all of these as we go along. Really good question. So this is a much better basic read-write policy for S3. This is just an example. I'm specifying exactly what I need to do, right? Very limited. And I'm also specifying the exact resources upon which I want to act. And this is sort of a little gotcha that has tripped me up I don't know how many times. If you're working with S3 and you want people to basically have these permissions on the whole bucket, the resource, you have to specify both the bucket name itself and everything in the bucket. /* do everything in the bucket. Because in AWS and S3, the bucket is a separate entity from the items in the bucket. So you have to apply that policy to both. But this is very specific. I'm saying, yes, you can put objects, yes, you can get objects, and you can delete objects, but none of the other stuff. There's about 100 other options I could put in there in S3, but I don't want people to be doing all of those things there. I want to limit what they can do, and this is the exact policy I gave to my developers and to our location applications when we're reading and writing from S3. I don't need my apps to do anything more than this, and that's a good thing to do. Now you may notice that in this particular policy, I didn't include a principal who can do this, and that's good to do, actually, because if you don't specify a principal, that means that that policy can apply to multiple entities, multiple users, multiple EC2 compute instances, whatever it is. So you don't always have to specify a principal. So this is just one view of what IAM and what it can do. There's a lot more you can do with it. You can restrict how a service is called. And this is a really restrictive example of this, and I'll sort of walk you through it. There's this new thing in the statement called the SID. I don't know why AWS are called this way, but it allows you to put comments into your policy, which is really helpful. Just to be able to, like, as you're reading through and saying, this is exactly what this policy does. But you'll see in this policy, our effect is allowed, and the principal here is an individual user. An actual individual user. In this case, it's an app. It's called the billing app here that I've done here. So I'm specifying a specific user in my account called the billing app. And my action is I can publish to simple notification service. I specify a topic called past due topic there. And I'm providing a condition. And I'm saying that this user can only publish to this topic if that request is coming from a Lambda function called check bill for past due. So we can be incredibly specific about how things are done in our applications to really lock down and ensure that only the right resources, and resources can include functions, right? Or only the right applications in our account are making the right requests to the right places. So you can be really, really specific in how services are called across your applications. Another example, you can use date ranges in your condition. So this is an example that says you can only write to a DynamoDB table during tax season. And I use that using this condition clause down here, where I have a date greater than and date less than comparison. So I can say only in this window are you allowed to write to this table. And I can go one step further and say only if the IP addresses that are making this request are those in this list right here. And of course I can substitute wildcards, down at the subnet level or something like that. So we can be really restrictive in how we write our policies. You can write a policy that ensures that all requests come over HTTPS to your S3 bucket. And in this case, we're using a deny policy here, right? We're saying the effect is deny if this secure transport Boolean is false. Meaning if it's an HTTP request, don't let it come in. Everything we do has to be over HTTPS. And you can write this for not just your S3 buckets, but for your EC2 instances that might be serving up a web front end, right? To make sure that everything comes into block it. The request will never even make it to your IIS instances, your IIS front ends. It'll just get blocked by AWS before it even makes that far. So they're really powerful. Policies are really powerful in that regard. Here's one that says, it specifies a resource, but it's a not resource. Meaning, okay, I don't want my development team to write to my audit log bucket, where I put auditing my stuff about who did what and when. Nobody should have right access to that team, to that bucket, but I want my developers to be able to basically access all my other buckets in S3, right, to do the work they need to do, except for this one. So I say not resource, and that means when I apply this to their accounts, that means they can access all my buckets except for this one. It helps for auditing. Make sure that nobody else can access it, helps for compliance right there. So really, mastering IAM, like I said, is about mastering policies. And I've only sort of shown you a little bit of what policies can do. There's a lot more to the policy language. There's a lot of really excellent examples out there in the AWS documentation. And this does, unfortunately, require a lot of trial and error. on your part. It's a simple reality. You have to figure it out, especially when you're working with a service for the first time, like, what do I really need? What don't I need there? There's a really great tool called the IAM Policy Simulator. It's available in the AWS console. This is where I do all of my work. This is where I debug my policies before they go out into production. I spend many hours in here. But basically, you can load the policy and then see what individual actions will get allowed or denied based on that policy. So you can make sure your policy is going to work as you expect before it goes out into production. Super useful. I spent a lot of time here because I'm that guy who gets to write IAM policies. Lucky me. So now we are, what, I don't know, 20 minutes into the presentation, you're like, okay, cool, great, where's ColdFusion? This is a ColdFusion conference, so let's talk about that, shall we? Now, in order to do this work, you actually need to use the AWS Java SDK, right? ColdFusion is Java, it's written on in Java, it runs on the JDK, so we're going to use the Java SDK provided by AWS to do this work. If you're using ColdFusion 2018, all you have to do is add the Java SDK jar file, it's a single file, to your CFusion lib directory. If you're using other runtimes, including CF 2016 and 11, which works back as far as 10, you would also have to add those other jar files that come bundled with the AWS SDK to your CFusion lib directory to make this stuff work. In fact, to make any of this stuff work in my AWS Playbox app, again, here's the URL. If you didn't get all those, listing all of that, it's in the AWS Playbox app. I blog about it. I have lots of links to that in there. Again, all the code that I'm going to show you is in the Playbox app here today. So, when you work with AWS Java SDK, there's a very basic pattern that you follow to work with it. And anybody who's worked with the Java SDK probably recognizes this immediately because it is one of the very consistent things in working with AWS. The Java SDK is really well written. It's very consistent in many ways. And if you saw Rashid's presentation in here yesterday morning about what they're doing in CF 2020, it is this exact same pattern that they're using. Slightly simplified, less verbose because there's a front end, there's a CFML front end on top of the AWS Java SDK. But basically, the pattern is this. You create a service object. In this case, we're going to point to IAM. You create a request, populate the attributes of that request. You tell the service object to run a function on that request object, and you get a result object back. You're going to be so sick of seeing this slide in the next 20 minutes. I promise you will just be like, you just get off of it. So here we are, to create an IAM policy, to actually go into your ColdFusion application and say, I need to create a policy that I'm going to then use to apply to users and groups and instances. This is the same thing. So we create an IAM service object, we create something called a create policy request object, we populate the attributes of that create policy request object, we tell IAM to create policy using the create policy request, and we get a result object back. All right, so let's search the code here because that's a lot more interesting. And hopefully you'll be able to see it from wherever you are. Oh, nice, look at that. Great. You can still read it, right? Hopefully no one goes into a seizure because of it. So we created, there's going to be a lot of this is going to be super fun. We create our policy, we create a reference to IAM in the AWS Playbox app. There's just a service factory that does that. We give our policy a name, because you have to give it a name of some kind. That's the one thing that's required. And again, all this code's in the AWS Playbox app. You don't have to capture it unless you really want to. And then we create a create policy request object. We give it a policy name. You might want to give it a description or not. That's up to you. And then in this case, I read my policy, the actual JSON structure, from a file. That's what I'm doing. I think this is really useful and really important because if you put your policies in files that get read in at runtime, put them in source control. And this is super important for debugging when all of a sudden something doesn't work and you realize because someone else who has IAM permissions in your account has gone in and muddled with the policies, you're like, why would you do that? Well, you can go back to source control and get the original version of the policy and see what went wrong and where. So putting them in text files that you read in at runtime is a really powerful technique because it allows you to keep them in source control. So we read in that policy JSON file. It's just a file to read. That's all we're doing in ColdFusion. We set the policy document as that policy JSON. We say, hey, IAM, go ahead and create my policy. We'll get a policy result back. And the most important thing you'll get back in any of these operations is the ARN, or Amazon Resource Name, remember that unique identifier of that thing. Because you're going to need it later on to refer to a number of other things that are there. So in our policies, as you saw in that one, if I go back and you can actually read it, I've specified my buckets that I want to do there. But what if you don't know the name of the resource in advance? You want to do it on the fly. Like you're creating an SQS queue and you're now going to say, I want people to have access to this SQS queue or this S3 bucket, whatever it is. Well, again, here I have another policy that allows publishing to this one simple queue service topic here. And I have this resource as %current topic error and %. It's a placeholder. This is what I do. You can do something differently, but I find this to be really useful. Because then when I create the IAM policy, I read in that file and then just do a simple text replace so that I can pull this dynamically. I don't have to have 25 different policies for each of my 25 different SQS queues that I'm going to be using. I just create it one time that applies to all my queues, and it works really well. It's just file read and then replacing a string. String replacement is an old technique, but it works really well when you don't know the names of things, or the ARNs of things in this case, ahead of time. That's all I'm doing. It's the exact same process that I showed you before, only here, I'm just reading it and doing a text replacement so that I can dynamically generate this stuff. Okay. So I think that's about all I'm going to talk about policies, because it's about 25 minutes here, 20 minutes. If you want to learn more, and you should always learn more, the AWS docs are actually really good at giving you lots and lots of example policies, particularly if you run EC2 instances, the actual sort of compute instances where we might run the ColdFusion application server. Policy, there's some really good examples in there on restricting what your EC2 instances can do in a very secure way, so I highly recommend looking at that. There's a complete and very handy and searchable and humane IAM reference by the folks at Cloud9. It's much easier to read through if you understand IAM, you're just looking for specific actions. That's a great resource. There's a great session from reInvent that's on YouTube. So Amazon, when they do their reInvent conference, puts almost all their sessions on YouTube after the fact. This is a particularly excellent one that is given by one of the one of the product heads for IAM. She's like an amazing presenter, lots of great detail about policies in a very short amount of time. And if you just want to get getting started with policies, this tutorial from Cole Morrison is probably the best one that I found as well. Again, you can take pictures of the slides. I'm going to post my slides online later on, as are all the other speakers. Still have access to all those links. Those are really good resources for learning more about policies. So now we move down the stack, and this question of where do policies actually get applied? Are they universal or not? And they're not, because really you apply policies to a number of different resources. The next one I want to look at is roles. And I'm only going to talk briefly about roles, because roles really only apply to EC2 instances. These are the compute instances where you might run a ColdFusion server, or a SharePoint server, or heaven forbid, your own database server inside of AWS. There's also roles that AWS provides for one service to talk to another. So if you ever use Lambda, there's a default role that Lambda has that allows it to do certain things by default if you don't specify your own. So roles are not associated with a specific user or group. Trusted entities assume roles. And a trusted entity in AWS is a compute instance. It is your EC2 server, for those of you who are using EC2. Or it is the Lambda service itself. They're not individual users, they're not individual groups, they are things that are established and controlled almost entirely by AWS itself. And what's great about roles is they allow you to share access without setting up access keys, meaning users. So if you're spinning up an EC2 instance, you don't have to create a new user for every single EC2 instance you might spin up. Because if you're a large company, you might have thousands of EC2 instances. And then to create thousands of users and rotate their access keys and do all that work is a huge pain. You can simply say, this EC2 instance runs in this role. It has all the permissions it needs for that instance to know what it can and can't do in terms of accessing other AWS servers. And instances assume roles through a service called Simple Token Service and through an action called assume role. So when the instance starts up, it says, hey, this is a Simple Token Service, I want to assume a role. And then Simple Token Service passes back the information that it can do that. So it makes a call to assume role, and then assume role provides temporary credentials to that instance, along with a time-based token that says this is how long these credentials will be valid for. And then your applications then get that token and that role information from the instance metadata that you have there via the AWS SDK. And then you can make requests across AWS to other functions that's there. And this is much more secure than hard coding credentials into your applications, right? And it also allows your applications, your servers, your individual servers, to take on different roles depending on what they need to do, right? You might have a PDF service, a PDF server that focuses more on PDF generation, or a task server, or a web front-end server. And you want these things to do different roles, and rather than hard coding all this into each of the individual servers, you can simply say, hey, I want them to assume the PDF role, or the task server role, or the web front end, or whatever it is. And this is sort of pseudocode, again, okay, for the screen, that shows you how you make this request via the AWS Java SDK. Basically, you say, hey, I want to assume this role based on the role name, and then from that, you would get credentials, including an access and secret key, a username and password, and a token that could then be passed around throughout AWS there. And again, this is the route you want to go with your EC2 instances instead of trying to hard code things in there. It is much, much more secure to go with roles than it is to just try and hard code all this and create users for each of your EC2 instances. And again, roles are just policies. Roles are just policies. They're JSON structures. That's all they are. They work exactly like policies. There's really no difference other than they're just called roles, and they're applied only to trusted instances, meaning EC2 compute instances or other services and for AWS. So that's really how I want to talk about roles, because again, they're very specialized and they're exactly like policies. They only apply to EC2 instances and trusted services. So they're specialized. Most of us have users to deal with. Let's look at users and how we deal with that. So we've looked at policies, we've looked at roles, now we're going to go on to groups. And groups are pretty easy, right? Pretty straightforward. They're a way of organizing users of individual accounts that might do things. And if there's one thing you want to take away from this section, it's that you want to make changes, you want to apply policies to groups, not individual users. It's a huge mistake to apply policies to individual users. Don't do that. So to create a group for your ColdFusion application, again, the same 5-step pattern. We tell IAM, we get a reference to IAM, we create a group request object, we populate the attributes of that object, and then we tell IAM to create a group based on our create group request object, and we get a result back. So again, here's the code. This is going to start looking painfully familiar to all of you. We say IAM, in reference to that. We give our group name our group a name. We say, okay, I want to create a create group request object. I give the group name, and then I say, IAM, hey, create that group for me. And we get a result back. And again, as usual, the most important thing in that result is the ARN of that group. So you can use that and refer to that later on. And again, it'll save you so much time, applying policies to groups, not individual users. So don't think of users as just being people. Users can also be accounts for running individual applications, EC2 instances, whatever you want it to be. Attach your policies to groups. It's much easier to make a change to a group and have it affect the 124 people inside of that group than to make a policy and then have to reapply it over and over and over again to 124 people. It is painful and tedious and not what you want to do. So always apply policies to groups, not users. To attach a policy or apply a policy to a group, you do the same thing. You create an attached group policy request object, we populate that attributes, and we tell IAM to attach group policy using the attached group policy request object, and we get a result object back from that. In code, again, this looks very familiar to you. We create our attached group policy request. We give it the group name that we've already created before, and the policy ARN. Again, this is where ARNs come into play. You need to be able to store these somewhere on your local machine, or in memory, or in a database, or some other secure location, so you know exactly what policy ARN you want to attach. Because in this case, you're creating a group name just by the name or the user, by their username, but when it comes to attaching policies, you really need to know what that policy ARN is. So that's something you'll need to store later on somewhere else in your application. Okay, so that's how you take a policy and apply it to a group. Now, users. The last step. People, instances, resources, applications. These are all different ways of being a user in AWS. And when you create a user account, there's one basic question you have to answer. Should this user have console access? Access to the graphical web interface for AWS, right? That's the console, as they call it. And in most cases, you're going to say no. There's very few people who should be ever accessing your AWS console. In fact, almost all of your accounts should never have console access. That's really the better way to go, because that forces you to do things programmatically, to do infrastructure as code, to script everything out for yourself. So in most cases, your users will not have console access, so they'll have a username, which is kind of irrelevant in most cases. And then an access key and a secret key. And this is like a username and password. Access key and secret key is like a username and password for AWS. But they couldn't call it username and password because if you do need console access, you're going to need a username and you're going to need a console password. So they couldn't just call it username and password. Plus an access key and plus a secret key. And it's through the access key and secret key that we do our work with AWS. In case this is not familiar to you, this is how you speak to AWS in code. Whether it's a command line interface, the AWS Java SDK, or any of the SDKs, or writing your own stuff, which you should never do, this is how you would actually get authorization, get authorization to do whatever you need to do inside of AWS. So to create a user, there's actually sort of 3 steps to that process. You have to create a user, create an access key set for the user, and then add that user to a group which has a policy attached. So to create a user, here's our 5-step process. Once again, we're going to do a create user request. We're going to tell IAM to create the user using the create user request, and we're going to get result object back. Again, here's how it looks in code, create user. So in this case, I'm just giving it a username. That's all you have to do. You create a user, just give somebody a username. It does need to be unique in your account. You can't have multiple users with the same name there. But you give them a request name, and you create that user, and then you get that user details back. The user details object is actually kind of important. But let me take a brief detour to talk about something called tags. How many of you use tags who are using AWS and using tags? A number of you, excellent, super, good. If you're not, start now, start today, start using tags. Tags are just really helpful for finding your stuff in AWS. Because if you're like me or many other companies, your AWS footprint grows, it sprawls. You get lots of users, you get lots of S3 buckets, you get lots of EC2 instances, all these other things that are out there. And it's hard to find them, it's hard to know what they are. And tags allow you to help you sort of find your stuff in a human readable way. And they're really just key value pairs. That's all they are. They're key value pairs you can attach to almost anything. Meaning like users, or policies, or EC2 instances, or Lambda functions, or S3 buckets, or whatever it is. And you can set these up. So you can say, for example, a tag, a pair, key pairs like department is security, or the environment is dev, or the data sensitivity is 4 out of 5, whatever you might want to put in there. And then you can actually do searches on this inside of AWS. You can create what they call resource groups based off these tags. And as your AWS footprint increases, it becomes so much easier to find things and most importantly, build the appropriate parties in your own team if you have tags. Otherwise, it's a nightmare manual cost process that nobody wants to go through. So use tags as much as you can. You can add them to users, you can add them to any number of different things here. They just make your life, especially if you're more of the AWS administrator in your organization, or if you're just a solo developer who finds yourself running 15 different instances for clients, having tags makes it easier for you to see which instances belong to who. There's a really good tagging best practices document inside the AWS docs if you want to learn more about them. And it's really easy to create tags. Again, I'm just creating a tag object. I give it a key and a value, and then I provide maybe an array of tags, so you can put multiple tags on an individual resource inside of AWS. And in my create user request, I'd say, hey, in this create user request object, set the tags. So I know that this user's department is IT security, or this user's department is marketing, or whatever it might be. This makes it much easier to run reports, find out who did what in what organization, or what part of the organization they belong to. So use tags, really, really helpful. All right, so back to our user creation process. We created our user, first step, cool, great. The next thing we need to do is create access keys for the user. And this is important because users have no credentials by default. AWS works on the principle of least privilege, so you can create a user, but that user can't do anything until you not only give it access keys, you also tell it kind of what policies, what it can do inside of AWS. So this is really important because it makes it a lot more secure, right? If you create users and they can't do anything, that's not going to hurt anybody. But if you create users that by default can do anything and you have to whittle away those permissions, that's incredibly dangerous, right? So this is much more secure by default. It's working from the principle of least privilege, as Amazon calls it. So to work with user credentials, again, same thing. We're gonna create something called an access key request. We're gonna give that a username, for the person who wants to have new keys there. And we're going to say, hey, IAM, create those access keys for me, and the result object will actually contain that access key, secret key, that username and password that you're going to need. So again, here we are in code. We create the request. We tell IAM to create the access key. And then you can see inside the access key object that comes back, the access key ID and the secret access key values can be gleaned from there. And that you can then use to have different users do different things in your accounts within AWS there. But two important things to know. First of all, once you create a secret key, you can never retrieve it again. So in the time of this request right here, where you create the credentials, after that request, you can never retrieve the secret key again. Very important, because you're like, oh, it'll be in memory, or I can just make the same request to get somebody's secret key. No. So if somebody loses their secret key, if you can't find it, doesn't have it anymore, gets deleted, their credentials are invalid at that point, from that point on. But more importantly and more dangerously, and I wish I had good advice for how to handle this for you, but I don't, you are then fully responsible for that access key and that secret key, to store it securely in some way. Because if you're working from a ColdFusion application and you want to be able to talk to AWS, your ColdFusion application needs to have that information somewhere in it, right? It needs to know the accounts that it can work with and to be able to authenticate using those credentials. And there's lots of different ways to do this. You can store this in like a vault, like HashiCorp's vault, or in a database, or whatever it is. Just remember, though, you are fully responsible for storing that information. Even if you're giving this out to the developers, somebody needs to store this information somewhere, and those developers become responsible for putting the credentials somewhere secure for themselves so that they can do their work inside of AWS. And this is a challenge. There's lots of ways of doing this, but you are responsible at the end of the day for that security. AWS, it's like somebody steals your keys because you put it in a GitHub repo, you committed that repo, it's a public repo. Someone's going to steal your keys, and then within minutes, I read a story not too long ago, you got 6 minutes for keys to be found and then immediately used to start charging up over $14,000 in billing in under 7 minutes. So never, ever, ever, ever put your keys in a public GitHub repo. Don't even want to be private GitHub repos. Because there are bots that scan for AWS access keys in GitHub repos. So just be really careful about that there. All right, so we created our access keys, great. And then we need to add that user that we created to a group that has policies attached. Again, add users to groups instead of policies to users. It's very easy and tempting to add a policy to a user. It'll be much easier in the long run as your organizational complexity grows, and it will grow, to attach it to groups instead. So attaching a user to a group, again, we do something called an add user to group request. We populate the attributes of that and tell IAM to add user to group using the add user to group request. Again, here we are in the code. In this case, all we have to do is their group name and username instead of their ARNs. One of the great inconsistencies inside of AWS's SDKs. But there they are. And then you get that result back. And this result is basically pass-fail, right? It worked or it didn't. It's not really a useful object to get back, unlike many of the other result objects we get back from AWS. Cool. User creation process, all done. We've created our user, the keys, policy attached. Now that user, whoever it is or whatever it is, can go out and do work. One of the things you probably want to do is rotate the access keys. This is a really good practice. If you're not doing it now, I highly recommend you build this into your workflow. It's easy to do from within ColdFusion to rotate those access keys every n days. Because when you create a user, when you create a set of keys for a user, it'll have a created on property that gets returned, and you can store that in the database and say, oh, it's been more than 90 days since Brian rotated his keys, so let's create a new set of keys for Brian. So that's really important to do. It's pretty easy to do. Again, basically, you would delete the existing access keys. You can set them you can update them, but I don't know why you would. I would just say delete them outright. I guess there might be like a microsecond in which you would have deleted the keys and new keys haven't been created, and you might get requests in there that are invalid, so I guess maybe that's why you want to do it, set the old keys to inactive and create new ones there. But that's the basic process. You use a create access key request to do that. Again, this is a little more complicated here, but we're saying we're creating a delete access key request. We do that first. To delete the existing set, we do another create access key request, and from that, we get a new set of credentials that we then have to somehow store securely inside of our application. And congratulations! You yourself, your application can now manage users permissions from within AWS from your CFML app. So you can ensure that people who are admins in your ColdFusion app have more admin privileges and the right privileges inside of IAM. And again, the code is not very complicated. It's all in the AWS Playbox app and pretty straightforward, I think, in that regard. But you can make sure, this helps you ensure, just by using a simple code, that what your users can do inside your ColdFusion applications maps to what they can do inside of any AWS service you might be speaking to. That includes S3 or anything else there. So really, I just want to show you briefly a little demo of the Playbox app working. I've already showed you the code, so I'm going to avoid showing you the code in here because that's not very interesting to go over it again. And I think by now you're like, hey, I get the pattern. It's a 5-step process, create, result, blah, blah, blah. And so let's just do that. Make our lives easier here. All right, so let me pull up Chrome, which I think is somewhere on my screen. There it is. This is my AWS Playbox app running locally here. And theoretically, hopefully the internet will work and I won't have a failed demo. We'll find out here. So in here, it does all these different things. There's it first creates a policy with rewrite permission to that AWS private Playbox private bucket that I showed you earlier, using the same policy I showed you earlier. So there's my policy name, there's my policy ARN, in case I need to do that. I set up a simple notification service queue there, or sorry, topic. I can create a policy specifically for that, saying that only this user can, send stuff to that policy. So the next thing I'm going to do is create a group here, because again, I'm going to attach my policy to a group and not an individual user. So I've created my group, this is that lovely group name here, and then got the ARN group there. And now I'm going to make a user. Again, it's all this code I showed you earlier. I go ahead and click on create user, and there's my user there. The name, the ARN. Oh, look, it's my access key and secret keys. So you can all have that right now. If you'd like to. But that user can only do something really specific. So if you want to do that really specific thing, meaning writing to this very specific bucket, you are welcome to do so. Get that there. And I can test this out. So I have another little page in here. Test out the policies, permissions for this user. So oops, I actually need to go back. Oh no. It's right here. I opened a new tab. See, I was smart because I knew I wouldn't pay attention and I wouldn't have my access key and secret key on here on the screen. So that's why I opened another tab. Clearly, I know my weaknesses in that regard. So I'm just going to copy this access key and secret key in here, and then I'm going to put a bucket name in here that I'm going to use to write to. Where's my bucket name? I tell them AWS Playbox private. But I need to enter it in lowercase because AWS bucket names are case sensitive. And I want to make sure to do that. And let me find a file that I want to. I didn't choose a file, right? I'll just go to my desktop. I'll grab my notes file here. And I should theoretically be able to upload that to that bucket. Cool, the file is uploaded, right? Because that user that I created only had permission for that bucket. But if I was changing the bucket name like to one of my other buckets in here, I'll take out the word private because I have another bucket in this account called AWS Playbox bucket. I'll go ahead and choose a file again. Same one, and it's going to throw an error this time because this specific user does not have permission to write a file to the AWS Playbox bucket. It only has permission to write to the AWS private bucket as well. So, simple demo of how that works. And by the way, if you look at the AWS Playbox code for this, I don't use ColdFusion's built-in S3 stuff for it because, and this is how I do it, is create a file, Java file object, and then populate the attributes of that and tell S3 to put that file object in there. The reason why I don't use ColdFusion's built-in stuff, even though it's very easy, is that it requires a larger set of permissions than I am comfortable giving that account. It pretty much requires S3 star permissions in order to work. So if you are using S3 from within your ColdFusion applications, it's slightly less than S3 star, but it's pretty darn close. And for me, that's way too open. And so I create my own permissions and write it using the AWS Java SDK instead. Is that more work for me? Absolutely. Is it something I'll talk to the CF team about when it comes to 2020? Absolutely. But in the meantime, I know that I have a much more secure way of putting up files because I'm not saying, here, do have all these permissions for this account. I'm only instead a very limited set of permissions that I want to go through. So that's the demo. It just runs through all the code that you saw in that I revealed to you or went over with you earlier here. Go back here, go back to the slides. So it's pretty straightforward, I think, in that regard. Yeah. But it works, and all that code's in the AWS Playbox app. A couple other things to keep in mind before we wrap up here is that the resources, when it comes to IAM, they are not limitless. You have a maximum of 1,500 policies that you can have per account. So you may want to think about this in terms of production. So maybe you need more than one account, which is a really, really, really good idea. We work with AWS. You might want to have a dev account and a staging account and a production account, because you're probably going to create a lot of policies, testing them out, see what works and what doesn't, and it should never go into production. And that will count against your 1,500 policy limit. You can only have 300 groups per account. Again, do things in dev, you're testing things out, you probably don't want to do that. Because again, if you have a really large organization, those 300 groups can become really, that limit can be really problematic for you. I believe that you can ask for that service limit to be increased, but they're really much more strict on increasing IAM service limits than they are on other service limits like the S3 buckets you might have, or Lambda functions you can execute concurrently, stuff like that. Because all that stuff you pay for. IAM you don't pay for. Right? So they're much more strict about raising limits for this kind of stuff than anything else. And you can also only have 10 policies attached to any given user, which seems like a lot, but if you're trying to write concise policies that can be reused across users and across roles or across groups, you're going to run into that limit pretty quickly. Right? Because you want to write a policy that's specifically for S3, a policy that's specifically for recognition, a policy that's specific for EC2. And then apply those to individual multiples to individual users, and they'll all work together. All will figure out what's allowed, what's denied, and all that good stuff. But it is a limit of 10 per user. That is something to think about, particularly on accounts that might have a lot of responsibility. Theoretically, what that might force you to do is have accounts that have very little responsibility. So there is this kind of burgeoning thing in AWS is dealing with lots of different accounts. And anyone who works there long enough has to deal with that, and you will wind up with lots of different accounts because it's a safer and more sort of secure way of running stuff in AWS by having accounts that have very limited number of policies attached to them. So I hope that in the last 40-some minutes, 50-some minutes, you've figured out that IAM isn't that scary. You can actually control it entirely from ColdFusion and your ColdFusion applications. And it's not hard to do. I mean, I basically repeat the same code over and over and over again with different object and function names because it's really easy to work with the AWS Java SDK. You just have to look up the object name, and look at the function names, and that's pretty much the same pattern you work with, whether it's IAM or S3 or Lambda or whatever it is that you might be using. It's a simple pattern, it's easy to use, which makes for me as a developer and as a manager, really easy to deploy this stuff on my team. It's a simple pattern that can be followed. Once you pick up that pattern, it's easy to use pretty much across all the different services. So try it out. If you haven't tried to do management of IAM permissions from within your ColdFusion apps, think about it because it's much easier to align what you're doing in your CFML apps with what's going on in S3 if you're doing it from within that home app, your source CFML app itself. Don't forget to fill out the session survey. Very important. You get entered in the drawing for every session survey that we do. And also, it's really important people like me who help run pick the sessions to figure out what's useful, what's not, what you'd like to see again in the future, or what you never want to see again in the future there. And finally, here again is the URL of the AWS Playbox app. I blog at brianclaas.net. That's where I'm going to put up my slides that you'll see here today. I write a lot about using AWS Java SDK in CFML, and I really appreciate the feedback that I get from the community on this. Someone just gave me some feedback on some old components that I had up for doing request signing in S3 and request signing in CloudFront to say like this request or this digital signature is only valid for an hour to sort of protect content that's up there. And I just did new versions of those components because somebody pointed out that, hey, your versions are ones that use the old request signing signature, the old request signing method, not the new one that Amazon now requires. I was like, oh, I should update that. So I post a lot of stuff about using AWS Cloud now on my website. You can also reach me at my Gmail address, of course, and I'm on the Twitter on occasion, and we'll gladly respond to people on the Twitter there. So that's it for me. If you have any questions, I'll gladly answer them. We got 5 minutes and then lunch starts, so you can all about anything. Yes, sir.
In your S3 example for the principal, if you want multiple users, you can specify a group in there.
Yeah, so the question is if you want to have multiple principals on an S3 policy, yeah, you would supply an array. You would just be there, an array of individual users that would be allowed to access that resource or operate that policy. Thank you, and